Hello, hi. This is Wenjiao Wang, and this is my report for cloud computing project, and this is task 2. So here is a layout of my document. So for the first part intro, the problem set is same as task 1. The only difference in requirement is that in task 1, we need to use batch processing method to process data and answer the questions. And in this task, we need to use streaming and stream processing for answering those questions. So I use two tools basically. I use a Kafka and Spark Stream. Kafka is a cluster that serves to collect all the messages from multiple resources and then distribute this message to subscribers. And Spark Stream is a cluster that can process stream data in micro batch manner, as we discuss in the lectures. So here is the data flow and also the flow of process. In task 1, I have finished a step from zip file, that's from the image that given to us, to uncompress it to CSV files. And in this task, because we need to stream process, so first step is to stream all the records in the CSV files into Kafka. And for that, I use the Lambda method to do this task. And after we feed all the records into Kafka, in AWS it's called MSK, managed service for Kafka. Afterwards, we can consume that stream, that Kafka stream, in the Spark EMR. And we can do further processing in the EMR. So that's a basic flow. And here is details of my configurations. Firstly, I started a Kafka cluster, and I used two nodes with this size, Kafka M5 large. And the Kafka version, I use the default one, 2.6.1. This step takes about 15 minutes to be up. And afterwards, I need to create a Kafka topic first so that we know which topic we can feed the data. So for that, I started another EC2 instance. And in the EC2 instances, the basic purpose is to set up the topic for the Kafka. So we need to download this package for Kafka. This is a client-side package, and unpack it. And then I can cd into that folder, cd into bin folder. There is a bash file, bash command file called kafka topics.sh. And with this command, I can create a topic. So here there are 4 variables that we need to set. One is a Zookeeper server. The Zookeeper server is basically the server configuration we have for the Kafka cluster. And you can get the server address from the configuration page. Replication factor, basically this means how many replica we want for each data, for each record. And this number cannot be larger than the number of brokers. And because the default configuration for Kafka, we have only 2 brokers. So here at most I can set 2. And partition 1000 is recommended for Kafka M5 large node. And the larger the partition number, the more parallel processing the Kafka can provide, and it's more efficient. And topic is just a random topic that I set for this stream. So after setting up this topic, I can feed the data into Kafka. And as I said, I use a Lambda method for loading CSV, and then feed each line as a record to Kafka producer. So firstly, we need to, here is some snip from the Lambda function. So basically what I did is that load the object and read it as a CSV and split all the lines. And then for each line, I call CSV.dictReader, which basically converts the line into an object. And then the producer is the Kafka producer. And then I can send this record, convert it to a JSON format, and send it to the Kafka topic. So this is a Lambda function for processing one CSV file, and in another Lambda function, I basically can launch the first method, Lambda method, for each file. So here for the launching Lambda file, I basically look for all the CSV files in the path and send the configuration pass it to the first Lambda function. And then all the files can be processed at the same time, simultaneously. To confirm that all the streams has been fed to Kafka, we can in the EC2 instance we can do this command on the bin folder. We can execute this Kafka console consumer command, and Bootstrap server we can get it from the configuration page for Kafka, and topic we can just use the topic we set, and then the stream of the record should be printed into a terminal. So that confirms that our records has been converted into records in Kafka. And the next step is to set up the Spark EMR. And I found that I need to use 3 M5X large nodes and choose the Spark function, choose the Spark pre-configuration. And here is a page that that shows the nodes I use, the one master and two core, two worker nodes, and in the applications I have pre-installed Spark. And to feed the Kafka streams into Spark, I need to install this. I need to download this jar and download it to this path. Basically, it's an external library for Spark that is used to connect to Kafka. And then on the bin folder, whenever I have my PySpark file ready, I can submit the job with Spark submit command and feed it into this jar, this downloaded jar, and with some other configurations, and passing at the same time passing the Bootstrap server for Kafka and topic for Kafka. And these two arguments are used in the code. And next, let me talk about the how I compose this PySpark file for getting a solution for each question. So basically, in each py file, I use this import to get a configuration for Spark get a configuration for Spark context, and also I need these Z2 libraries for stream processing to connect it to Kafka. And basically, I call this method Kafka utils.create a direct stream to register consumer for Kafka into Spark. And for different questions, basically, I need to use different map and reduce methods. But here, I use the first two questions as an example, and following the group 2 and group 3 questions are similar. The only difference is that they use the DynamoDB, which is similar to task 1. So for question 1, it asks which is the busiest airport. So basically, I get a stream. This is the raw data. Then I flat map. This is a map method. Map it to what? Map it to get the origin field and append with number 1, and also get the data field and append with number 1 as well. And the flat map, that means we have for each record we created these 2 entries for both origination airport and the destination airport, and for both of them we count as 1. And reduce by key is for each micro batch, we are reducing all the records by this method. Basically, we are counting, we are getting the sum for each airport. And update the state by key, that means for each micro batch, how we update the record. So here, the new means the value of current batch, and we are summing it. And orig is the original rolling state. That is a result by previous batches. And what we want is just a sum of them. We just need to update the state value. And transform, basically, we are ordering based on the second field. And then finally print the result. and that will give us this result, this table, and this is basically the same as what we get in test 1 for batch processing. And for question 2, it asks for each airline, for each carrier, which has a better performance. So for this one, it's not that simple because it asks us to calculate average delay for among all the batches. So what I did is that for each record, I tracked the delay time for each flight, and have additional field 1 then to mean that we have one flight with this delay. And then in reduced step, we are summing up both fields, both the delay time and also the number of flights. And in update method, which means updated state for each after processing each micro batch, we need to recalculate the average delay time based on the past average delay time and the number of flights, and also the new delay time, average delay time for the new batch, and also the number of flights. And afterwards, we need to recalculate the average delay time for all the batches and updated state. And finally, we get this table. This is also same as batch processing. And for group 2 and group 3 questions, yeah, similar. I will not go into the details for map reduce and update methods. And they are basically similar to group 1. And I just use the DynamoDB for catching the intermediate results. And for group 3 as well. And finally, in conclusion, I successfully utilized the Lambda function to feed the data into Kafka, and then use the EMR Spark for stream processing to answer these questions. And I think the result is satisfactory. Here is a reference I used for setting up EMR with Kafka. And also I have some screenshots for recording the Kafka metrics when I'm streaming the data into processing into the EMR. And also the screenshot for printout solution for group 1. That's all. Thank you.